Ever since our school days, we have been taught that the Big Bang resulted in the formation of our universe. However, the James Webb Space Telescope has just provided evidence that challenges the Big Bang theory. What did the space shuttle find that has shaken the scientific community? Let's find out. The formation of the first galaxy was a crucial moment in the universe's history, marking the beginning of a long process of cosmic evolution that led to the countless galaxies we see today. While our understanding of this event is still evolving, ongoing research and observations made by telescopes like the James Webb Space Telescope are shedding new light on this crucial chapter in our cosmic history. Constructing a galaxy is challenging. The oldest galaxies discovered by the James Webb Space Telescope in November were formed 350 million years after the Big Bang, even though the universe is 13.8 billion years old. Not only did the young universe take its time creating its initial galactic masses, but once it didn't create huge ones. Scientists need to reassess some fundamental cosmological principles or their knowledge of how the first galaxies were seeded from tiny clouds of dust and stars to explain the appearance of such enormous galaxies so early in the history of the universe. These objects are much more substantial than was previously believed to be feasible for galaxies so soon after the Big Bang, dating to a time when the universe was only 3% as old as it is today. If confirmed, these findings would challenge scientists' understanding of how the earliest galaxies formed. A team of researchers led by Joel Lahar, an assistant professor of astronomy and astrophysics at Penn State University, has made an exciting discovery using NASA's James Webb Space Telescope. The team was analyzing the first data set provided by the telescope, which is equipped with infrared sensors that can detect light from the farthest reaches of the universe. To their surprise, the team found galaxies that are much more massive than expected. These galaxies are as mature as our own, even though they were thought to be from the earliest stages of the universe. According to Dr. Lahar, the discovery challenges existing theories about how galaxies form and evolve. One of the co-authors of the study, Dr. Erica Nelson from the University of Colorado Boulder, noticed a group of fuzzy dots that stood out in the photographs. Upon closer inspection, these dots turned out to be exceptionally bright and red, indicating that they were massive and had been around for a long time. Because light is stretched, or redshifted, as it moves through the expanding universe, redness is used as a proxy for age in astronomy. These galaxies appear to have existed for 13.5 billion years, making them 500 to 700 million years old. These wouldn't be James Webb's oldest galaxies, which began operations in December 2021. For galaxies that are roughly 350 million years old were discovered by scientists last year, although these were much smaller. According to calculations, the most recent galaxies were comparable in mass to the Milky Way and included tens to hundreds of billions of sun-sized stars. Lahar made a remarkable discovery that presents significant challenges to the field of science. The discovery is so unexpected that it raises doubts about the prevailing understanding of how galaxies formed in the early universe. The term Dark Ages typically refers to a period in the early universe from about 380,000 years to around 150 million years after the Big Bang, when the universe was filled with a dark, opaque fog of neutral hydrogen and helium gas. During this time, there were no stars or galaxies yet formed, and the cosmic microwave background radiation had just begun to cool and become transparent. These times are thought to have occurred after the cosmos experienced rapid expansion and spent a few hundred million years cooling down sufficiently for gas to consolidate and collapse into the first stars. During this time, galaxies started to form. The discovery challenges previous theories about the dark ages of the universe and suggests that star formation may have occurred much earlier than previously thought. However, the astronomer notes that further observations are needed to confirm these findings and discard outdated models. The statement also acknowledges the groundbreaking work of the James Webb Space Telescope in revolutionizing our understanding of the universe. The group intends to get spectrum photos offering more precise distance data and enabling better mass estimations. The spectrum will immediately tell us whether or not these things are real, Lahar claimed. Compared to the size of contemporary galaxies like our Milky Way, which is thought to have at least 100 billion stars, the first galaxies were frequently dwarf galaxies with perhaps 100 million stars. According to the rule, early galaxies were pipsqueaks, or at least that used to be the rule. In a new study just published in Nature, objects with populations of tens or even hundreds of billions of stars have been found that are estimated to be at least 6 galaxies that date back as long as 500 million years after the Big Bang. The mass of the greatest of the 6 is estimated to be 10 times larger than the Milky Way, or 1 trillion times greater than our Sun. In a statement following the research publication, co-author and assistant professor of astrophysics at the University of Colorado Boulder, Erica Nelson remarked, "It's crazy. You simply don't anticipate that the early cosmos was able to organize itself that swiftly. It shouldn't have been possible for these galaxies to form." The Webb telescope made observations last summer of a region of the sky close to the Big Dipper that had previously been captured by the Hubble Space Telescope. However, Webb sees primarily in the infrared, whereas Hubble sees primarily in the visible spectrum, giving it a new perspective on a region of space that Hubble had previously found nothing particularly noteworthy. The new study's results were intriguing. 6 blotches of extremely brilliant red yet fuzzy light stood out from the background image, which was otherwise ordinary. The color was what initially drew the astronomers' attention. The cosmos constantly expands, and as things get farther away from us, their light wavelength gets pushed into the red spectrum. The further away anything is, the redder its color. It was determined that these 12 objects were sufficiently far away and red enough to have formed up to 13.3 billion years ago. Additionally, they were large enough to be galactic in scale rather than point sources of light like a star or supernova. However, that initial perception of size might have been deceptive. Gravitational lensing is a phenomenon whereby light from distant objects in space can be distorted by the gravity of foreground objects, making it appear larger than it actually is. Albert Einstein first proposed this idea, and more than a century of studies have proved it. The new paper's authors found that objects that appeared on a cosmic scale were considerably smaller than they seemed to be and were only optically exaggerated. But that notion was quickly abandoned. A closer look at the complete image showed that no foreground items were close enough to the 6 bright lights to change their size or shape. That left galaxies as the most likely candidate to account for the objects, though even the researchers agree confirmation will require additional observations. Even so, there are just as many questions as answers surrounding the likelihood that they are, in fact, galaxies. The galaxies would have been explosively abundant for starters. 2 new stars are thought to be born in the Milky Way each year. The 6 galaxies found in the latest measurements would have needed to form hundreds of new stars every year for hundreds of millions of years to grow as big as they did as quickly. Furthermore, the heavier elements that make up modern stars were not present in the early universe. Instead, hydrogen and helium were stars' primary building blocks, resulting in relatively small galaxies. If ones this large were produced at such an early age, it would imply that heavier stuff was in fact more prevalent and present than previously believed. Cosmology is the study of the origin, evolution, and structure of the universe as a whole, including its physical properties and fundamental laws. Scientists use observations and models to understand the universe, and they strive to create models that accurately predict the behavior of cosmic phenomena. The area of the sky where the new objects are located will, in fact, be thoroughly covered by other observations, even though G is a small word with significant implications. Currently, the Webb team can only approve about 200 applications out of the 1,000 requests for telescope observing time they receive annually from astronomers worldwide. Observations of the new bodies with the telescope's near-infrared spectrograph, NIR-SPEC, which examines target objects' temperature, mass, and chemical composition, will undoubtedly be a part of some of those investigations. NIR-SPEC should validate the validity of the 6 candidate galaxies. It will fundamentally alter how we think about how quickly extensive mature galaxies can develop and form. Remember to subscribe to our channel for the latest insights.